In problem number 11, we are going to graph a log equation. So my log equation is an inverse of exponential. It's going to have this shape, which is the inverse of exponential function. So my base here is 3 because I have log base 3 of x equals y. I am going to pick easy values for x. So 3 to the first power, that's the way I'm going to do it. So 3 to the 0 power is 1. So when my y value is 0, I get 1. So 3 to the first power is 3. So I have 3, 1. And then 3 to the second power is 9. So I have 9, 2. Make sure you pick easy values. Your graph needs to look like this. In problem number 12 and 13, I'm going to write these as a single log. So I'm going to use my log properties here. I am going to first take the 6 and the 4 and then make them exponents. So I have y to the 6th, w to the 4th. Next thing I'm going to do, when I'm adding the exponents, I'm multiplying the bases. So I have log base b of y to the 6th, w to the 4th. Here are my log rules that we have been using. The next problem, I notice I have minus here. So that means I am going to divide my bases. So I'm going to go 60 divided by 10. That's how I got log base 2 of 6. In problem number 14 and 15, I'm going to expand them. So I am going to make it more than one log. If I am dividing my bases, that means I am going to subtract my exponents. In problem 15, I'm going to multiply these out, which means I'm adding my exponents. That's how I got addition here. And then I'm going to take my 5, which makes a power for power, and move it out front. That's how 5 got here. In problem 16, you're going to use your scientific calculator. And your scientific calculator only does base 10. This problem says log base 3. So I'm going to put a common log in the denominator. And then I'm going to say log of 44 in the numerator. So I'm going to go ahead and calculate that. On number 17, I'm going to do the same thing. I'm going to make sure I show my work. So I have log base 9. So log base 9 goes in the denominator. Log of 68 goes in the numerator. I'm going to plug that into my scientific calculator, and that's what I got. In problem 18, I'm going to solve this. This is one of the ways you can solve this. If I factor 27, I get 9 and 3. And I factor 9, 3, 3. So I get 3 to the 3rd, and I'm going to take 6x, put it over there. I'm going to factor 81, 9, 9. And then I'm going to factor 9s. That's how I got all those 3 to the 4th power. I have the same base, so I'm just going to drop the bases. So I'm going to go 6 times 3, that's how I got 18x, equals 4. And then I'm going to divide each side by 18 to get x by itself. I got 2 9ths. On problem 19, I would factor these if I could. But 5's already prime. 42 will not give me factors of 5. So I can't factor them. But I can take the log of both sides. So I'm going to take the log of both sides. So I could take this 7x and use my log rules and bring it out front. I want to get x by itself. So I'm going to divide both sides by log of 5. 1.62325, that came from log of 42. I plugged that into the calculator. now I got 7x by itself. I'm going to divide by 7. That's what I got for a solution. Take this number, plug it back into the calculator to see if it's correct. In problem number 20, I have different bases here, so I can't factor it to get the answer. So I'm going to take the log of both sides. When I do that, I could use my log rule and bring 3x out front. So on my calculator, I'm going to go log of 87. That's how I got this number. I want 3x by itself, divide by log. Do that on your calculator. Then I do have 3x by itself, divide by 3, so I get that solution. Plug this into your calculator, see if it's correct, and it is. In problem number 21, I have different bases here, so I can't factor. So I am going to take the log of both sides. So I can take 2x, bring it out front. So my calculator, I'm going to go log of 150. That's how I got that number. I want to get 2x by itself, so I'm going to divide by log of 5.5. So I end up with 2x equals this, divided by 2, so I can get x by itself, and I did. So I'm going to take this number, 1.47, plug it into the original equation to see if it's correct. In problem number 22, I want to solve for x, and it's already a log. So first thing I'm going to do is divide by 3, so those two will cancel each other out. So that's how 4/3 is how I got 1.3333. I am going to change this to an exponent to get rid of that log. It's a common log, which means my base is 10. So I'm going to go to the 10 to the 4/3 power. Plug that into your calculator. That's how I got 21.5453 equals 2x. Then I'm going to divide by 2. That's how I got this number. And I plug that back into my calculator to make sure it's correct, and it is. In problem 23, I want to get rid of the log, so I'm going to change it to an exponent. So it's a common log, so my base is 10. 10 to the second power equals 3x plus 5. 10 squared is 100. So I want to get x by itself, so I'm going to minus 5 from both sides. So I get 95 equals 3x. Divide by 3. I got that answer. Plug it into your calculator to make sure it works in the original equation. And it does. In problems 23 and 24, I'm going to make these into a single log. My natural log is just log base e. So all the rules for logs apply to natural logs. First thing I'm going to do, I am going to take my 3. Take that 3 and make it your exponent. That's how I got 7 cubed. Take this 3, make it into an exponent. That's how I got a cubed. Now it says plus, that means I'm multiplying my bases. So I have natural log of 7 cubed, a cubed. In my next problem, I'm going to do the same thing. I am going to make it a single log. I'm going to take the 2, make it the exponent. That's how I got a squared. I'm going to take 3, make it the exponent. That's how I got b cubed. If I am subtracting, that means I'm dividing my bases. So that's how I get a squared over b cubed. In problem 26, I want to solve a natural log problem. A natural log, my base is e. So I want to first get rid of that natural log. So I am going to go e to the 3rd power. That's how I got e to the 3rd power equals 4x minus 2. On my calculator, e to the 3rd power, that's how I got 20.0855 equals 4x minus 2. I'm going to do the opposite. I am going to add 2 to both sides. So that's how I got this problem. I want x by itself. I am going to divide by 4. That's how I got this answer. Plug this answer back in to check on your calculator to see if it's correct, and it is. In problem number 27, I want to solve this natural log equation. First thing I want to do is get rid of this 2, so I am going to divide it by 2. That's how I got 12.5. To get rid of e, which is really irrational number, I am going to do the natural log, because that's log base e of e. This is 1, so this cancels each other out. That cancels each other. So that's how I got 2x plus 4 equals the natural log of 12.5. Put that on your calculator. That's what you get. I want to get x by itself, so I'm going to go minus 4. Then I'm going to divide by 2. That's what I got. Check it on your calculator. In problem number 28, they're giving us a model to solve this problem, and they're telling us y is the number of lawnmowers sold, and they're telling us after 6 years. So the number of years is 6, so I'm plugging 6 into that equation. I am going to round to the nearest whole number, so that's how I got that answer. All of this equation right here says the total amount after 6 years. That's what that says.